These last couple of identities are not actually in the course. Okay, so this is a little bit of an extension, if you like. They used to be many years ago. For some reason, they decided, oh no, you don't need to know these ones. But funnily enough, in a couple of years' time, they're back in the new one. Anyway, here's what they are. What it allows you to do is turn a product into a sum. And so where it basically comes from is the sine of alpha plus beta formula. So if you think about it, when you expand it out, you get sine, cos, cos, sine, so you get a multiple of 2. So if I want 2 lots of sine, cos, well then I'll get sine, cos, cos, sine, but then in the other one I'll have sine, cos, cos, sine, one will be plus, one will be minus, the second bit will cancel out, so you have 2 sine A, cos B. Then you get a similar one, cos, cos, well that must have come from the cosine formula, because you go cos, cos, sine, sine. And then if you add another cos, cos, sine, sine, the sine, sines could cancel, or alternatively, if you wanted sine, sine, if you did a subtraction, the cos, coses will cancel. So here's our formulas. 2 sine A cos B, and that's where it's sine plus sine. Cos, cos is cos plus cos, whereas sine, sine is cos minus cos. But notice something with the third one. It's the A minus B first, not the A plus B. Okay. I suppose actually, now I think about it, it would have been smarter to write the first one as A minus B, because with the addition it doesn't matter, does it? Gee, I wish I'd thought of that. That would have been easier to remember. Okay, pretend it's always A minus B in the first one. So it's always going to be A minus B. It's always going to be A plus B in the second one. And then all we need to know is, well, sine, cos, that obviously came from the sine. Cos, cos is the cos. Sine, sine is cos minus cos. Ah, easy. Okay. Something like this. 2 cos 5x sine. So I've got cos sine, or sine cos, depending on how you want to say it. So that must have come from the sine one. Just to get it into my head, because I prefer sine cos rather than cos sine. So all I've done is swap the 2 round. So it says, oh look, it's sine cos. It must have come from the sine formula. So it's A plus B, A minus B in this case, 5x plus x, 5x minus x. We get sine of minus 4x. Sine, of course, is an odd or even function. Odd. So it's the same as minus sine 4x. So I could rewrite my product as a sum, or in this case, a difference. If I had cos, cos, well, cos, cos must have came from the cos formula, but it's actually half of 2. Notice my formula is 2. So it'll become a half of cos 3 theta plus 5 theta plus 3 theta minus 5 theta. Cos minus 2 theta. See if he can redeem himself. Cos, odd or even? Even. Very good. So, cos of minus 2 theta is the same as cos 2 theta. Let's say we had to work out 2 sine 45 cos 15. Well, yes, I know the exact value for sine 45. All right, I could work out the cos 15. But let's do it this way. Sine cos, so it must have come from the sine formula. So sine of 45 plus 15 plus sine of 45 minus 15, sine of 60 plus sine of 30, root 3 on 2 plus a half, root 3 plus 1 on 2. Alright, let's go the other way. What happens if we've got a sum and we want to turn it into a product? These are probably more useful, to be honest. You do this more often than you would the first ones. So sine plus sine, there it is, 2 sine half A plus B cos half A minus B. Or as I prefer to think of it, 2 sine half sum cos half diff. Right, so sine plus sine, 2 sine half sum cos half diff. Cos plus cos, you can see it's a similar thing, but we've got 2 cos half sum cos half diff. Notice they're both cos half diff. Right? So sine, this is easy to remember so far, 2 sine half sum cos half diff, cos 2 cos half sum cos half diff. Now, cos minus cos, oh, how do I remember this one? Well, cos minus cos, that's a bit different. So I know my answer is going to be a bit different. So I say minus, instead of just 2, minus 2 sine half sum, sine half diff, because that's a bit different. See, because cos is different to sine, and so it's all a bit different. So here we go. Watch how we do it. If I have cos 3a minus cos 5a, well, hang on. It's a bit different. I've got a minus there. So it's a bit different. Minus 2 sine half sum, sine half diff. Well, the sum, 3a and 5a is 8a. The difference, 3a minus 5a minus 2a. Half of 8a is 4a. Half of minus 2a is minus a. Sine of minus a. Sine, of course, is an... So therefore, we get 2 sine 4a sine a. Sine minus sine. Because remember the formulas were sine plus sine, cos plus cos, cos minus cos. We didn't have a sine minus sine. The reason we didn't bother with a sine minus sine is because I can turn that negative sine 4x into sine of negative 4x, because sine is, of course, an odd function. Very good. So we get 2 sine half sum cos half diff. Where is it useful? Well, maybe something like this. Say you got an equation like this. Sine x plus sine 3x equals 0. Well, what I could do is say, hang on, no, I'm not going to do that. I'm going to go sine is 2 sine half sum cos half diff. Cos is, of course, an even function. 2 sine 2x cos x, but now I've got a product equaling 0. So I can say, oh, well, either sine 2x is 0 or cos x is 0. A lot easier than an addition equaling 0. So we get our possibilities. 2x could be 0, 180, 360, 540, 720, which gives me possibilities for x of 0, 90, 180, 270, 360. Cos x equals 0 gives me 90 and 270. Oh, I already had those answers anyway. So therefore my final answer is 0, 90, 180, 270, 360. Right. I've only picked, how many questions? Hardly any questions. 1, 2, 3, 4. I only picked out about 6. As I say, not actually in the course, but have a bit of a play with them. You never know. You might find them useful.